Hello and welcome. In this video / potentially video series, I'm going over building a trading bot simulation in Python. The idea is to extract the live price feed for the Bitcoin price, extract relevant information out of it, and apply certain logic to the data feed so that you can design a trading strategy out of it later on. To be more specific, I will design a live price Bitcoin feed and calculate the price development over a 30-second period. This time horizon is just made up to make the concept clear. Here you can do whatever time horizon you're interested in. I picked a very short one, obviously just to be able to showcase it in the video. So the challenge here is to get the price as of now, set it into relation to the price within a 30-second window. Meaning after 30 seconds you will need an updated price anchor point and the calculation starts again. With that you can design a certain strategy, like if the price was rising or dropping by a certain amount within a certain period of time, you want to enter into the position. Besides the buying condition, you can also use that to implement a take profit, stop loss or trading combination out of those. Very important to mention, we keep the price development window fixed, meaning after 30 seconds have passed, you reset the price development calculation. So you start from scratch again, meaning from the price after the 30 seconds have passed. So your price development at that point is 0. So you start your calculation from that point on again. The more dedicated approach here is to have a rolling calculation, meaning you always consider the price 30 seconds before the current price without re-anchoring. So you keep the look back window rolling. We will do that in a potential follow-up video. Here we are keeping things as simple as possible. For now, let's get started step by step with a fixed look back window calculation. First of all, we need some libraries. Websocket to establish a connection to the Binance servers to receive live Bitcoin prices. JSON to transform a JSON object from the Binance server to a Python dictionary. And pandas for data handling. That's it, library-wise. Then I'm going to define two variables here, init price and init timestamp. Both are set to none. So what are those variables? The price is containing the reference price and the timestamp is containing the reference timestamp. Meaning these variables are going to update as soon as we are getting data flowing in. So whenever we are getting data flowing in the first time, this is being set. So the first price flowing in with our data feed is going to be our initial price. But as we didn't establish any data feed yet, I'm setting those variables to none. And as soon as we receive the first data tick, these are being set. And these variables are going to be updated every 30 seconds, as these are the reference price and timestamps. So initially we don't have any price and timestamp information, so I'm just setting them to none. Next, we are going to establish the live price data feed. As I've worked with Websocket and setting up Websocket data feeds or Websocket price feeds, I'm just jumping over it. So what I'm doing is simply copy pasting from the Websocket documentation. So I'm defining a function on message, and that function, so def on message, is just organizing what to do when you receive a message from a socket or WebSocket server. This needs a WS, which we will define in some seconds, and a message, which is the actual message from the server. Now, within this function, we have to, and that is very important, get those two variables in the global variable space, as this function is being called every time when we receive data from the server. So potentially every 30 seconds, these variables are going to change. So we need to be able to change those variables within this function. So I'm just getting them in the global variable space by defining them as globals. So global init price, global init timestamp here. With that, we can manipulate them and get them in the global variable space. Now, what else to do in this function for now? I'm going to define a dictionary here. I'm just calling that dict underscore. And this is simply using the JSON library and loads the server message. What this is going to do is simply taking the message from the server and transforming that to a Python dictionary. So this is just a dictionary. And before moving on, I'm just going to print that out to show you what we are getting on each server message, because then it's easier to understand what I'm doing in the next steps here. So as said, this is just getting the reference price and reference timestamp into the global variable space, so we can make changes within this function to those two variables. And then it's just printing out whatever the server delivers us. We still have to define this WS, and this is again just copy paste from the library, just copy pasting that here actually. So get out of this function, then define WS, so WebSocket, WebSocket app, then the socket, then on message, and then run it forever. So we still have to define this socket, and that is very easy to find. This is just in the Binance WebSocket API documentation. So I'm just copy pasting again. I will reference that in the video description. So we need to define socket as this one here. So as said, this is just copy paste. I'm just taking the K-line 1 minute stream here for my live price feed and define that as socket. So I've gone over that in more detail in some of my previous videos. I will try to link it in the video description. But as said, mostly copy paste from two documentations. First, WebSocket documentation. Second, Binance WebSocket API documentation. Okay, so this is going to print out the message from the Binance server on this WebSocket stream, so Bitcoin USDT, on the 1 minute K-line stream. And it's just printing it out every time you receive data from the server. So if I'm running this, you will see that I'm getting the following. You see that I'm just getting a live tick here every second. So let's take a look at that. So what do we got here? Let's stop that so it's not that annoyingly updating all the time. So you see we are getting a dictionary with a ton of information, which we don't need as a whole. So I'm just doing some filterings here. So what do we need? We need the timestamp, and that is this event timestamp here. So that is a so-called Unix timestamp. We will transform that to a human readable timestamp in some seconds. But this one is telling us when exactly was this happening. And here you have some information, but for us relevant is the close timestamp here. So that is the live price of the Bitcoin currently. So we just need to extract from this dictionary the event timestamp and the price. That's all we need for now. So let's actually do that, and we have to do that within this onMessage function. So what we are going to do is just defining some additional variables here, which is the current price. And the current price is this dictionary. Then you access the data dictionary again. So you just take dict, then index for data. Then you're getting to this level of dictionary. And then you get to K, which is containing the close which you need. So this is the next level of dictionary. So you need to index for K. And then you're in this level of dictionary, and then you can simply extract, see the close price. So this is just your current price, and as you see, this is currently string formatted. You want to have it as a numerical value, so you are just doing a typecast here to a floating value. That's it. So with that, you are getting the current price. You also need the current timestamp, this one here. So just defining TS here for timestamp, then take again the dictionary. Then what do we need? We need again to access the data values, data, and then directly in this level of dictionary, you just access capital E. All right, and as you would just get a Unix timestamp value, I'm using a very handy pandas function to just transform that to human readable timestamp, which is just pandas to datetime then provide this Unix timestamp and define the unit as ms. So let's print out what we are getting. So we are printing out current price, or let's take timestamp and current price. And with that, we should get this in a more dense format here. So let's run this again. Important, whenever you run this again and you made changes to the init price and init timestamp, you have to execute that again. Otherwise, you're getting new referenced prices and timestamps. You will see that in some seconds. So executing that and executing that again. And you now see very conveniently you are getting a current timestamp, so this one here, and the current price, updated every second here. As simple as that. So we have now dense information, we have relevant information, and we can move on to what we discussed in the beginning of this video, implementing some logic into that. So let's stop that for now. So what is the next step here? The next step would be to define our initial timestamp and our initial price variable. And how can we do that? We need to define if this initial timestamp and price variable is actually a non-value, which is initially true. So because they are non-values before this stream is running, you just define a condition here. If init timestamp is none, then you want to assign your init timestamp to the first timestamp value. So in the first data tick, let's say this would be our first data tick, you will get the timestamp as this one here, right? And in the second data tick, this wouldn't update, because it wouldn't simply update because the init timestamp is not none anymore because it was assigned to a value. So this will only be triggered in the very first data tick. If, and I just mentioned that, if you reset those variables before running the stream, which is critical. Now you can also define if init price is none, but it's redundant. If you have a timestamp, you also have a price value. So I'm just defining init price as the current price, same argumentation as before, avoiding some redundant code here. But if you feel more, if you feel better assigning that to also if init price is none, you can also do that, but you don't need to. So you have an initial price, which is, let's assume again, this is our first data tick, this is our initial timestamp, this is our initial price, and this is only going to be updated once, that is when starting the stream. So we have an init timestamp defined and an init price defined as soon as we are running the stream. Now we want to know how far this current timestamp and this current price is away from the reference one. So in other words, in easier words, what is the difference between this timestamp and this one, assuming that is our initial timestamp? Same for here. What is the price development? So the price here, as you see, was dropping by one cent. You wanna know what is the difference between the current price and the initial price. And then same logic for the subsequent values. What is the difference between this one and the initial one? This one and the initial one, right? And so on and so forth. So how can you do that? You first define a time delta, just calling that time delta, and that is just the time difference between the current value and the initial value. So you can use pandas time delta function for that. You can also work with the data module that is on you. So this is calculating a time delta, and you want to have the time delta of the current timestamp, TS, so that would be in the second data tick, this one, and the initial timestamp, that would be this one, so minus init TS. So with that, you're getting the time difference of those two. Now, this I want to have in seconds, so it's easier to calculate with that. So with that, I'm getting this difference in seconds. All right, so with that, I have my time delta. And now what do I want to do with my time delta? As I said in the beginning, if my time delta is above 30, so if 30 seconds have passed, then I want to reset my initial timestamp. So let's take a very simplified example here. So let's say I take 5 seconds or whatever that is in the first 5 rows here. Then it's taking the time delta here. So time delta between this one, 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 until 5 seconds have passed. And then this is my new reference or my new anchor point. So this is my new timestamp, my new init timestamp or my new reference timestamp, and this is my new reference price. Okay, so this is then calculating the difference or the price development between this and this value. So in this case, I see that the Bitcoin was slightly rising within 5 seconds. And it's also telling me what is my time passed from here until here. And then the calculation starts again. Then this is my reference, and then I have this next one, but now it's benchmarking against this one, same as this one. And that is happening every 30 seconds. So how you can implement all that talk into code? You take a condition, if my time delta, which is in seconds, is larger, you can also take larger or equal to 30, then you want to reset your init TS, and your init TS now becomes your TS. So after 30 seconds, it's going to be reset. Then you also reset your price, as I just showed you. So you set your init price to the current price, and then it's going to start from 0 again. So you also want to get your price delta here, and your price delta is simply your current price minus the initial price. So you are just getting what I showed you. This difference you're getting. So your difference between your current price and the last reference point. All right. So you're just taking, price delta is my current price minus the initial price. So let's put that all together and work with some print statements so it's more clear what is happening here. So let's get rid of this print statement for now, and we start with, we are printing the current price. So the current price is just my current price variable. And then we're doing that with all what we defined, so the picture is getting more clear what we were doing here. So current timestamp is the TS. We want our initial price. Initial price is our init price, and want our initial timestamp is our init TS. And we want our price delta. So we're printing out price delta. And now let me go over that with you again so that is more clear. So we are, very important, resetting the init price and the init timestamp here again. And then we are running this whole structure here. Now let's take a look at the output. So first tick here. It's jumping down now. Wait a second. So first tick, you have a current price and a current timestamp. That is the very first data tick. And you see that the initial price is becoming this first price you're getting. Also, the initial timestamp is getting this first timestamp you're getting. So this is the initialization part. The price delta obviously is simply 0 because the current price minus the initial price is the exact same. So these are the exact same values. Then the data tick is flowing in, and you have a current price of this one here, and you have a new updated current timestamp. The initial price is still the same as before because 30 seconds haven't passed yet. And now you have a price delta. Now the current price is below the initial price, and you have a price delta of 1 cent here. All right. And then this is going further until 30 seconds have passed, and then it's starting over again. That's it for this video. Thank you very much for watching, and I'm looking forward to see you in the upcoming videos. Bye bye.